RISC-V computers are going mainstream, but they're still poking along at Intel Core 2 Duo levels of performance, at least according to Geekbench. This processor was all the rage in, well, 2009. But performance is only one thing I want to talk about. This single-board computer is actually a pretty big single board compared to something like a Raspberry Pi. This is the Jupiter, and it's the first RISC-V Mini ITX motherboard I've tested, and Milk5 actually sent me two. More on that later. But being a full motherboard, it has nice things like front panel I/O, 24-pin ATX power input, and a full PCI Express slot. What does that mean? Well, for starters, I can build this thing into a full PC, like using the Fractal North that I bought when I was 3D printing its little baby brother for a Raspberry Pi. Video on that, and how much a noob I am at 3D printing, is over on my second channel. But being ITX means you can deploy it in any PC case, even this little rack mount tray for my cute 10-inch rack. And the companies building these RISC-V boards are betting it all on a future where RISC-V is neck and neck with x86 and ARM for everything from servers to desktops. But before I try it in here, I'm gonna pop it on my Testbench and see how it performs. Because if there's one thing I've found with all the other RISC-V boards I've tested, it's that they're slow. Like slower than a Raspberry Pi 3, which is almost a decade old now. All the RISC-V SBCs I've tested so far are based on older chips using an older RISC-V spec. This board is based on the SpaceMint M1, one of the latest RISC-V chips with 8 x60 CPU cores running at 1.8 GHz. It won't be blazing fast, but it is the fastest RISC-V board I've tested. And before I get to results, I should mention I have the fastest M1 version of the board. The lower spec models come with the K1, clocked a little slower and with 4 or 8 gigs of RAM. But getting right into it, here's the Geekbench 6 results. Now, Geekbench is interesting. A lot of people tell me I shouldn't put much weight on Geekbench, especially on RISC-V. And they're not wrong. Geekbench's code is closed source, so we can't really see exactly how it's running its benchmarks. And are they as optimized one architecture to the next? Not sure. But I still like it for two reasons. First, it gives some hard numbers based on code that exists in the wild. A lot of apps are in the same boat, where they aren't optimized for every platform the same. So in that sense, if you see some wild results, maybe the code libraries underlying them could use a little love. All that out of the way, the 8-core M1 is faster than the JH7110 I've seen in the other boards, but at least for Geekbench, most of that speedup is coming from having more cores, not necessarily from the cores being faster individually. The current Raspberry Pi still trounces them though, and RISC-V SBCs are about on par with a Pi 3 now, at least for CPU. To further illustrate that point, I also ran my HPL benchmarks, and it shows a similar story, except here, the speedup from the SpaceMint M1 is way more apparent. It's still nowhere near a modern Pi, and better ARM chips like the RK3588 go off the charts in these graphs. The efficiency is improving a little, but it's still nowhere near ARM, and not even Intel or AMD yet. Linux kernel compilation is a little better, and it's also a more realistic workload. This is also the first time I was actually able to get one of Milk5's boards to even complete the test. So it's not fast, and compatibility is a work in progress. Why would anyone ever buy this thing? Well, the biggest difference between this and the older boards is this is the first processor I've seen with RVA22 and RVV 1.0 support. RISC-V is reaching a maturity level that should let devs optimize things better now, like when ARM introduced its Neon architecture. This year's also the first time I've tried out Bianbu OS, an Ubuntu derivative SpaceMint seems to be pushing. But before I show that and set up the full desktop, I wanted to talk to someone who's been using RISC-V a lot more than me. I asked Chris from Explaining Computers about compatibility. He recently built his own RISC-V NAS, and I was wondering if he had any struggles.
I didn't have to do any setup at all. I just literally installed the image and it worked. And it's worked extremely well. It's been very, very stable. You know, the performance is exactly the same as OpenMedia Vault on, for example, the Mini PC I was running it on for a while recently. So it's been very good.
I know that a lot of the boards that I've tested, like especially when the Vision 5.2 came out and all that, they were really good for enthusiasts or developers or people like you and me who are exploring the ecosystem, but they weren't good enough for mainstream users. Do you think that's changed or is changing?
I think it is changing. I mean, and I think it's changing a lot because of the software as much as the hardware. You know, if we go back to sort of mid-2022 when I started running desktops on RISC-V boards, you know, when you made a video, you had to make sure you recorded everything because you knew it was all going to crash and you might not get back to doing the same thing again. You know, it was really, you were lucky to get something working. And then by 2023, we were starting to see much better software support. It was still developmental, but things were starting to work. You could have some faith things were repeatable. I spent a week using RISC-V as my only technology, and I managed to do most things other than video editing perfectly successfully. And I think even from then it's moved on. You know, the boards I was using there were mainly the Cyped Light Pi4A Division 5.2, and their software development has continued very successfully across the last 9 months. And then now this year we've got, as we were just talking about, Banana Pi that I've been using with their Bianbu OS. Again, the software's been the thing that's really driven it. And again, it's more and more stable. You know, it's not consumer stuff yet. It's still development boards and development software. And I want to stress that, but it is much more usable than it was and much more stable than it was.
We also got to discussing a big difference we've seen in the ARM ecosystem versus RISC-V. With RISC-V, do you see that, is it on the same track? Is it going faster? Is it moving faster towards mainstream acceptance? Or is it on the same kind of track that it will be 5 or 10 years before we really see it take off?
I think it's moving faster. And one of the reasons is that the manufacturers of the boards are much more into the software development. You know, a lot of the ARM manufacturers, with the exception of Raspberry Pi, they tend to go, here's a board, and we'll let the community get on with the software. And they love launching new boards, new production run. They use new components, give it a new name. And that means it's very difficult for developers to keep up with what on earth they're supposed to be supporting. Basically by saying, we'll wash our hands of the software and let other people get on with it, which is what a lot of, to some extent anyway, our developers do. That's not what we're seeing in RISC-V, where you're seeing the people putting boards out, they recognise that they need to support the software and they need to keep supporting it. We don't see that in the ARM ecosystem.
With the Jupiter, it's the first board I've seen and thought, I could make a real computer out of that. And Chris agreed. There are some geopolitical reasons for it too, which I won't explore in this video, but Chris argued we'll be seeing reasonable open RISC-V desktops probably sooner than we see the same thing with ARM.
We can run a stable desktop with a browser and, you know, all the basic stuff, Office packages, etc. And so it's just waiting for someone to do it. But that would be a political decision. But when it happens, the hardware is just about there. So it's a very different thing from ARM, where there was never anybody pressuring to say, oh, we need ARM desktops. You know, we've got ARM chips in mobile devices, and then it's like, can we run a desktop too? Oh, we can. But there's no GPU drivers. Who wants to do it? Well, no one wants to do it. And RISC-V is a completely different position. There is a big impetus to say, can we make successful RISC-V end-user devices? And for that reason, I think they will happen.
Okay, so we have this board. We know the state of RISC-V. My next question is, if I install this thing inside the standard ATX PC case, how much of it would actually work like a real PC? The fastest way to find out? A build montage. Few quick things I found out while I was doing the build. Everything just fit together perfectly. It's a nice case. I like some of the features, like it has a little peg that holds the motherboard in, so you can build it vertically like this without it falling over all the time. Also, I used a Pico PSU that's 250 watts, so it's like a whole, it's kind of a PSU. It's more like a breakout board, and you use a power adapter, like a brick, that you plug into it. But it's one way to do ATX power on something like this. But if you do that, you bypass the 12-volt DC input on the motherboard, and you have a little thing that hangs out. And so I put it through one of the PCI Express slots. That's probably not the best way to do it, but that's what I did. You could also use just a standard old ATX power supply. The fans are not plugged into anything because I don't have an adapter from like Molex to fan. I might have one, but I couldn't find it. So that is, I think that's one improvement they could make to this particular board, have 1 or 2 fan headers on it. It'd be really nice if they were PWM controlled, but otherwise just having a fan header so you can power case fans would be nice. Not that it really needs it. With all this mesh, the airflow coming in here is going to be enough to keep the board from throttling with the little fan on it. So I'm going to plug this in, and I think it will boot up immediately. Yeah, it looks like it's booting. Now, an interesting thing is when I plug ATX power in, there's actually a little power LED on the motherboard that lets me know that there's power on. If I plug in 12 volt power or USB-C power, that little LED doesn't light up. So there's no other LED on the motherboard that indicates when power is on, which is a little bit annoying. But it looks like it is booting. And I want to test the front panel headers. I haven't done that yet. So I have my mouse here with its little RF dongle that I'm going to plug in to one of the USB 3 ports. And I have my headphones here, which I'm going to plug into the headphone jack. We'll see if both of those work. So here's Bianbu OS. And RISC-V is not blistering fast, but it's also not terrible. But you can see, like, even just logging in, the mouse is just kind of sitting there. I'm moving it, and we're not seeing any activity yet. This is pretty typical. You definitely have to be patient. But here's the full desktop. And if I open up Chromium, we'll see how long that takes. It's funny, I have this localized in English, but there's still, every once in a while I see a little bit of a, like there's a little Chinese glyph there. Not sure what that is, if it's like a slash, because it's the 1st of August today. Okay, here we go. So let's start off by going to youtube.com/Jeff Geerling. And I'm going to put my headphones on and see if I get any sound. And we'll click on our overclocking video. So it is working. I don't have a speaker on me, but you can hear through the headphones. Okay, so here's the video. And I'll turn up the sound so you can hear what it is. Today, I'm hoping. So sound is working. The only problem here is that it can't really play back 1080p content. So if I go to quality settings, oh wow, that's 360. 360p and it's still struggling. So I'll get on a 240p. See if that can do it a little better. So it can do 240p, maybe 360p. Going along with the theme of this is not a machine that's built for everyday common use, watching YouTube videos, watching Netflix or things like that, playing games. Those things are not what this is for yet. This is for developers. So you have Docker installed on here, and if I say Docker run hello world, then it's going to pull the image. And while it's doing that, I'll tell you the story about why I have 2 of these boards. The first one they sent actually had a hardware bug with the Wi-Fi. I'm not sure what exactly happened, but we ran a bunch of diagnostic tests and it found out that the Wi-Fi chip was just not being recognized. When it tried to load it, it wasn't working. So they sent me another one and it works perfectly. Everything else on that first board worked perfectly. It was just the Wi-Fi, so take that what you want. And you can see that the Docker Hello World worked. Now I have a whole article on my blog going over how to get Docker things working on RISC-V. The Hello World works and some images work, but a lot of images don't have RISC-V versions. So you'll have to either build your own or wait for those to come out. And that's why they're trying to get these machines out in the world so people like me can rebuild my Docker images and make them work on ARM, x86, and RISC-V. The other thing is I also have Ansible running on here. So there's a couple little things with Python that don't work correctly in RISC-V out of the box. You have to tweak a few things or install from source sometimes. So that's just something that happens. It was like that in ARM 5 or 6 years ago, and today almost everything just installs out of the box on ARM. So RISC-V still has a few growing pains like that, but again, that's why they're sending these things out. Some other software that I've tried, LibreOffice works fine. You can type documents and work on spreadsheets and stuff. Everything is slightly slower. That's just how it is with these boards. Super TuxKart works, OpenGL works. It's not gonna, set any speed records again, but it works and it has an Imagination GPU inside. Now, it all works and probably a bit better than I expected. And the price for this board, considering it has the CPU, RAM, motherboard, and everything included, it's not bad. This version cost $115, but the base model with 4 gigs of RAM is only $60. That's a whole RISC-V motherboard for the price of a Raspberry Pi 5. But this stuff's still not ready for prime time for consumers yet. It's meant for developers building and testing their software on RISC-V. And for devs, it's pretty fun to see a third architecture rising to prominence. And we can thank ARM's popularity for making a lot of build tool chains easier to use with multiple architectures. And before I wrap up, you might have noticed I haven't installed this graphics card. Let me know in the comments if you want to see whether RISC-V is better or worse than ARM for graphics card support. Until next time, I'm Jeff Geerling.